Now, we've briefly discussed video cards in the past, and it is important to know that the interfaces typically available for installations of a video card are the AGB, PCI, and PCI Express. So make sure you know that information, and you also need to know about comparing the video connectors and knowing the different information about that, such as a VGA. Typically, you'll see the blue on the end of the VGA, and that's the DB15. Know your different interfaces and variations of your digital visual interface, or DVIs, and that, as I mentioned in previous lectures, that DVI-D only transmits digital data, whereas DVI-A only transmits analog data, and DVI gives you the best of both worlds and supports both analog and digital signals. Make sure you really look into this port information. You might have also seen composite video on a card, and you've probably seen this before on some of your devices in your home, where the composite video uses red, green, and blue. Those are mixed into the same signal. Now, this does not produce a sharpened image as a VGA or S-video, but composite video is still highly used. S-video, you don't really see this a lot, but it is used on some TVs and video equipment, and you might even find some older laptops or even video cards inside a computer that has a S-video, and you'll recognize that from the port easily. Now, you also see sometimes a DVI or a display port that was originally designed to replace DVI, but they have not really made a good push in replacing them as expected. HDMI, that's pretty much a standard right now. Everyone uses the HDMI because this transmits both the video and audio over one cable, so this allows for a lot greater ease for just having one cable instead of multiple cables. So just make sure that you learn about your HDMI technology, as it is pretty much the standard at this point. And as always, when you're looking for a cable, you can always find that you have a cable for everything. You might find one that's a display port on one end and it goes to a mini display port on another, or HDMI to a mini HDMI in case you're using a tablet and you want to present that onto your 60-inch TV at home. You might just plug that mini HDMI into your tablet, the other HDMI into your TV, and now you're broadcasting from your tablet to the display on your TV, and you might be able to see that information better. Or if you're presenting to some people, you have that ability to just use that, and it makes it far greater quality than some of the other type of technologies. And sometimes you don't have the software needed to be able to transmit wirelessly, so you can use those type of cables, but there's always a cable to connect from one device to the other of so many different technologies. Now, we've mentioned storage devices prior to this. You'll see we have different types here. Some of these storage devices might include the USB flash drives, which are so popular everywhere, memory cards, or even optical discs. And when you're using these devices with your Windows computer, you'll find out that when it comes to using those in your device, Windows will assign a drive letter for each storage device that you connect with your computer, and that these need to have a file system, and this file system is used to manage data stored on that device. The overall structure the OS uses to name, store, and organize files on the drive are based on this file system. There's different types of file systems you'll come across: NTFS, exFAT, FAT32, and FAT. You can always find out what type of file system is being used on various measures, but here's one way: is when you've installed a flash drive. Let's say we were using an SD card for this example here. We just go to my computer and we look at the device. We right click on it, select properties, and you can see here in the properties window it's showing us that our file system that's being used on this SD card is indeed FAT32. So make sure to recall, if you're ever having to format a storage device, what type of file system is needed for that. And we've discussed that already in previous chapters, so if you need to, go back and reference that material. And I'll just say again that formatting is just the process that removes all the data from a device and creates a new file system. And just as a reminder, a file system is just a way for an operating system to store data in a structured format on a storage device. So just keep those two pieces of information in mind as you're thinking about your storage devices. Now I want to talk a little bit about optical drives and some of the standards used by optical drives. You have CDs, DVDs, BDs, or Blu-ray discs, and they use similar laser technologies where just different pits on the surface are represent bits used by a laser beam. CDs use CDFS or compact disc file system. DVD and Blu-ray uses UDF or universal disc format for its file system. We need to know about the data being written to these types of media. On a CD, you're only writing data to one side. On DVD and Blu-ray discs, you can write data to one or both sides of that type of media. You need to know about the capacities too. So storage capacities on CDs, DVDs, and BDs are very important. A CD can only hold up to 700 megabytes of data. Not a whole lot of data in today's terms for storage. Now a DVD that's a single layer holds all the way up to 4.7 gigabytes of data. So it's a big difference from going to a CD to a DVD. But if you're using like a dual layer DVD, now we're talking anywhere from up to 15.9 gigabytes of data. So a big difference going from a single layer DVD up to a dual layer DVD. And that's a dual layer and dual side DVD. You can even go up to a Blu-ray disc that is double side, double layer, and take up to 50 gigabytes of data that can be written to those discs. So you definitely need to know about the different storage capacities on those different devices. Now, one type of technology that is sometimes used is label flash or light scribe. And this is the ability to burn labels on the top of the disc. So burn that actual physical image of some type of graphics or print onto the disc for easy recognition when you're looking at, rather than using a label or a marker. When you are using markers, or if a customer is using markers to mark their discs, make sure they're using the proper markers, because your permanent markers can do damage over time to the media rather than a type of marker that is designed for disk operations. Now I want to conclude with some solid-state storage, such as USB flash drives, memory cards, and SSD drives. SSD drives are the new standard for physical storage in a computer. We've mentioned it before, but solid-state drives are definitely the way you want to go when replacing hard drives, for the speed as well as the lack of mechanical parts that can go wrong. You've probably heard USB drives been given many names, such as a flash pen drive, a thumb drive, jump drives, key drives. So there's a lot of names used out there. They all mean the same thing. When it comes to these, based on the size of them, you'll either use a FAT or exFAT file system. And as I mentioned earlier, Windows 7 and most of your Windows operating systems already have embedded drivers to support flash drive technology. When I talk about memory cards as one of our solid-state storage devices, memory cards can be used in various things such as digital cameras, tablets, cell phones, MP3 players, etc. SD association, or secure digital association, is responsible for standards such as 1.x, 2.x, and 3.x. 1.x is your regular SD cards. Your 2.x is for SD high capacity. You might see that written on the labeling as SDHC, and you might even see SDXC, which is your extended capacity, which is your SD association standard of 3.x. Now, SDHC and SDXC slots are backwards compatible with SD cards. You cannot use an SDHC card in an SD slot or an SDXC card in an SDHC or SD slot. So you just kind of become familiarized with those technologies and those standards. So here's just an image to kind of show you those technologies, and so you can kind of figure out and memorize this type of capacity that these have. You can see that the standard SD only holds up to 2 gigabytes of data, and you've probably seen some examples of these cards before. And you have the full-size, mini, and micro that are available. And you can see that down with our extended capacity, we do not have a mini SD that is, out there for use, but we do have a full-size SD card and a micro SD card. And you can see that those can go anywhere from 32 gigabytes of data capacity to be able to store up to 2 terabytes, which is obviously going to be a very expensive micro SD XD card. Well guys, that's it for my brief overview of Chapter 8 over supporting input, output, and storage devices. There's lots more information in the chapter. It's a lot of grinding work to just memorizing a bunch of facts, but it's all going to be helpful to you as a support technician out in the field, as well as supporting your own devices at home. So thanks for joining me with Chapter 8, and I'll